MestreCast, analytical chemistry software in a fast-changing world, with Santi Dominguez.
Hello, everyone, and welcome to MestreCast. My name is Santi Dominguez. I'm CEO and co-founder of Mestrelab Research, which is a company in North Spain, which focuses on analytical chemistry software solutions. In this episode of the MestreCast, we'll be talking about lab automation with Dr. Niccy Tonge, a strategic account director at Mestrelab. And automation is an area of a lot of interest to us, and therefore there will be a number of episodes that will be dealing with this subject. It is a great way of helping scientists do the daily work, and it is one of the main topics that our company is working on. This is the first episode of an automation series, as well as other topics, and Niccy will be sharing with us her knowledge and point of view about automation in laboratories. And after talking to Niccy, we'll be talking to Dr. Gary Sharman, Dr. John Horton, and a few other guys that know a lot about this, and I'm very excited to hear from. Niccy, welcome to the MestreCast.
Go for it, Santi, and thank you for having me as the inaugural guest.
Well,
I'm excited.
It's a great honor for both of us. Okay, so let's go, Niccy. And maybe the first question that I have, obviously we're used to thinking of robots as something which is just in science fiction, right? And I certainly grew up, I'm very geeky from that perspective. I grew up watching movies where there were lots of robots. You know, my first ever movie in the cinema was actually Star Wars, A New Hope. Even though at the time I didn't even realize the movie was called A New Hope. I thought it was just called Star Wars. You know, but obviously that was a long time ago. So the question is today, from your perspective, are robots here and are they impacting our daily lives?
Absolutely. Robotics and automations are really changing our world. Bots are absolutely everywhere. You know, we find them in so many places, from providing customer support on insurance websites all the way through to industrial robotics, which are involved in car manufacture and food production. You know, wherever you look these days, robots are there. They're taking over routine tasks, they're speeding things up, and they're increasing our productivity. I mean, there's things like ChatGPT, which took the world by storm almost overnight and created a revolution in the way we think about preparing text and answering questions.
ChatGPT, I think, is amazing how quickly it's come from nowhere to basically, like you say, being everywhere and being extremely useful from that perspective. And I can no longer remember how I worked before ChatGPT was here.
Yeah, I mean, robots are everywhere, and they're changing the way we work and driving developments in all sorts of businesses, from finance through to the pharmaceutical and chemical industries that we work in. I mean, it's amazing, and it's exciting.
Yes, absolutely. And sorry, I nearly jumped in there before you finished, but I think it's because I'm very excited too. And you mentioned one thing that I think is where I want to go with the conversation, which is you included chemical industry, pharmaceutical and chemical, right? Which is where Mestrelab plays, you know, and that leads me to the obvious question, which I think is of interest to people in the audience. I don't suppose we have many people from finance or automation or automotive listening. But we probably have a lot of chemists, or hopefully, or let's say a high percentage of however many people are listening will be chemists. So, you know, do you think automation is already relevant and significant in chemistry as a field?
It really is. I mean, robots are rising already in the world of chemistry, from, you know, small scale robots in a little lab preparing the odd sample for analysis through to high throughput synthesis, and automatically controlled large-scale manufacture, which is going through continual optimization in like inline reaction control and sampling. Robots are there already in the chemistry world. And I've seen some really exciting stuff in the last couple of years that really got me thinking about where stuff's going in the future. And I've seen some really cool AI-driven processes to propose new drug candidates, with companies aiming to automate end-to-end design through to production, and aiming to have their first molecules synthesized by these automated AI processes literally by the end of this year. So yeah, it's really cool and exciting. And then within the area of automated synthesis itself, there's things going on like self-optimizing reactions, which are being developed with probes that feed back into the decision-making processes to push and optimize a reaction towards a specific variable. So, for example, optimizing maybe for a given product, or perhaps optimizing a reaction to minimize the reaction temperature or minimize side products, or any of the other variables that you might optimize a reaction for. And it would take a human, forever, a really long time to explore all of these possible combinations of different variables and optimize them for all at once. But with robotics and automated analysis and processing the data with the results fed back and informing the next step in the reaction, the synthesis can run autonomously and continuously. So yeah, the traditional and some might say conservative world of chemistry is really changing. And yeah, it's going somewhere really exciting where humans interact with automations and robots and do some really innovative and inventive chemistry way faster than we ever could before.
Yeah,
it's cool.
It's funny. It's funny for me when you talk about some may say conservative chemistry. I think, in fact, we have that conservative chemistry written somewhere in an article in our website. When I first saw it, I thought it was a political statement. Then I realized it was more. It was more about a way of working, And for me, I don't come from chemistry originally, so it's interesting to see, in a way, I would say, how late automation has arrived to this field, in some other fields, like, for example, automotive, which is big in Galicia, where Mestrelab is based and where I come from. Automation has really been a huge paradigm changer and a productivity driver since, I would say, the 70s. So in a way, arriving in the chemistry field, which, by the way, I find much more interesting than the automotive field. Sorry if there are any automotive engineers listening to the podcast. I was actually amazed by how there was practically no automation at that time. Yeah, I'm going back to kind of 2004, So it's been a long time coming, and I agree with you with, I see a lot of these processes myself. I think I am absolutely, given the complexity actually of what chemists are trying to achieve, I'm absolutely amazed by some of the things that are now being done. And I love, I don't really have a love for traveling anymore, but I do love to go to some of these laboratories where some of these things are being done. So, and maybe following or taking the conversation from the global world more towards the Mestrelab world, which, this is, after all, the Mestrelab podcast series. What about analytical chemistry? Do you think that at the moment it already can benefit from this? It probably can benefit from this automation, right? But is it benefiting from this automation already?
Actually, yeah, it is. The analytical world's been benefiting from some kind of automation for actually quite a long time. So, there's sample carousels sitting on the top of spectrometers, and then predefined injection runs for chromatography, so that getting the physical analysis done isn't so much of a showstopper these days. Automations are already helping and increasing productivity for analytical chemists. Actually, probably maybe even a little bit too much. If you've got instruments running 24 hours a day, 7 days a week to maximize the return on investment in your hardware, what that means is that all of a sudden, data processing and analysis and extraction of the information and knowledge is becoming a really big bottleneck. And I hear several times a week, every week, from scientists who spent years at university studying to become experts, and they're so frustrated that they spend huge amounts of time each week routinely processing data, and then they're manually extracting integrals or peak positions or some other parameters and pasting them into spreadsheets to analyze and report. And it's time consuming and it's tedious, and you can get so many errors that you identify too late, and then it takes just so much time for these experts that they don't have the mental energy to focus on tasks that would really benefit from their training and expertise. So putting a set of tools designed to automate the processing and analysis of analytical data directly into the hands of scientists who are really going to benefit from them benefits the business at the same time. I mean, I think it's a real win-win. And I guess that's why tools like Mnova Gears have been created.
So Niccy, I guess that what you're doing here now is you're changing the subject of this discussion. You're moving from the rise of the robots to the rise of the scientists, right? Because you're describing a situation maybe in the last few years when, because of the ability that we have to obtain so many samples or to analyze so many samples so fast, but humans are still have the usual limitations, let's say. The scientist was a little bit becoming the slave of the robot, right? So the robot spits out analysis, and the scientist, basically like a slave, tries to make sense of those as fast as possible to keep up with the hardware automation capabilities. This is something that, for example, Arthur C. Clarke was already worried about in the 1970s, and there are a couple of really cool novels around humans being slaves to robots or to technology, you know. But basically, I think what you're telling me is that, and I don't want to refer back to Star Wars, but the rebellion has started and scientists are fighting back, you know, and that's great. And you mentioned something specifically, which is Mnova Gears, which in that context, I guess it will be maybe the equivalent to a X-Wing fighter from the Star Wars world. So, you know, can you tell us a little bit more about what, and when you say Mgears or Mnova Gears, what is this? What are you talking about here?
Right. So analytical data, it's really rich in information, and that we know that scientists need to be able to make more of it, both now and in the future. So we created this tool called Mgears, which is a no-code software which enables anyone to really quickly and easily configure and then run automated routines on their analytical data.
And Niccy, sorry, I just jump in there. When you say we created, we're talking Mestrelab here, right?
Yeah.
Yes. Okay. Great. And you know, of course, typically when you say a name of a manufacturer, you have to say something like other manufacturers are available. In this case, I don't think is the case. So, guys, no other manufacturers are available. But sorry, Niccy, I interrupted you. So do carry on.
So Mgears can be used for all sorts of stuff, from analyzing like large batches of data to maybe generate patterns and trends from the data, through to things like operating in real time to analyze data on the fly, and maybe even preparing your analytical data into machine readable formats to feed it into the future for AI processes. So once again, we're back to AI. So Mgears itself is a really super powerful and flexible or customizable tool that enables the automated extraction of information and answers and knowledge from your analytical data. So we've got a bunch of different automated workflows that we've already created, Mgears. These use NMR data, and I guess Mestrelab's super famous for being the NMR people, but we're not just the NMR people. We work with other techniques as well, like LCMS and IR, as well as Raman data. So we've built this engine, Mgears, with flexibility as well as scalability in mind. So pretty much any workflow, from simple processing of data and perhaps pushing it into an ELN, right through to really complex routines that push and pull data around an ecosystem of IT and integrated analytical instruments, and then feed that data into decision-making processes, can be set up and run. I mean, these tools, they're so versatile, and I'm really excited about them. You can run these tools as a desktop automation, you know, manually triggering the analysis of perhaps a batch of a well plate optimizing a chemical reaction, or you can deploy them on a server and it's going to automatically execute different analyses on the fly, context switching as different data becomes available and pushing the results through to the next stage in the process. So yeah, I'm really super excited about the possibilities that Mgears brings for getting more out of everybody's analytical data.
Okay, and I'm glad you actually said that last phrase, because you talk about a lot of things at the same time. And to be honest, I was wondering where I was going to go next, right? Picking on the things that you were telling me. But maybe that last thing that you said is worth exploring a little more, getting more out of the analytical data, and to me, again, this is a very interesting subject, and I guess you're driving at, and I guess my question then will be, once you have analyzed the data for the purpose that you run the analysis at this specific time, is it typically of use anymore? Is that it? I mean, has that data served its purpose and is its life in a way finished, or is the data of use further beyond? Now I'm moving from Star Wars to Star Trek, but never mind.
So I think in the past, the analytical data might just have been lost. But my goodness, nowadays, no. Analytical data is and should be an asset to any company that's working with it. It contains so much information about the chemistry and all sorts of things, from trends in impurity profiles through to all sorts of stuff. There's so much information in the data and it's not being used and it's not being made available to the rest of the organization at the moment. And that's often because the analytical data gets siloed into a computer, hooked up to a spectrometer, and it's not on the network, it's not shared with anybody. So only a small bunch of experts can really get access to it. And there's often no way to quickly and easily search through it, and sharing it even around a single site, let alone a global organization with sites in several countries, is difficult. So the problem really is that the analytical techniques themselves evolve faster than the ability to share the data and make use of the data. So it end up trapped and siloed in isolated informatics systems, restricted perhaps into vendor-specific software, stored locally, and maybe even duplicated here, there, and everywhere, with no real way to identify and connect all the data. So, a set of tools that really archive and preserve the complex analytical data were few and far between. And yeah, it stopped what should be an asset being made more use of and from being learnt from. And nowadays it's possible to feed your analytical data into ideas generation and development processes. But it's kind of a bit of a problem to manage and use it really efficiently.
Yes, and I guess that speaks to many things. Like, obviously, it speaks to data repositories, it speaks to things like data lakes, it speaks to data standards, maybe, right? So that there is interchangeability and interoperability. I don't know why I even try to say these words when we're recording. But, obviously the podcast is mainly focused on automation. So, I really understand the value of the data as an asset. I like assets, in the end of the day, I run businesses. So assets, I look at a lot of balance sheets and assets are always in my mind. But, if we are to make data an asset and we really are to exploit that value, maybe what I think is interesting in the context of this series is, how does automation help us do that? How does automation play a role in making data an asset that has further value to the organization?
That's a really good question. So at the same time as processing the analytical data that we need now to extract information, automation engines like Mgears can be used to deposit raw, processed, unreported data into a database, or even a data lake or some sort of data hub. And then the idea is that the data is preserved within the context of the chemistry, and it's made searchable and accessible to the entire organization. So it really does become an asset. So it can happen at the same time as the data processing. Maybe the scientists can do it, but if you can come up with a way of doing it with automatically, then there's no need for the scientists to even think about doing it. And at the same time, we can set up these automated processes to prepare and convert the data into machine-readable formats so that it's going to be made future-proofed and it can be used by these AI processes that we're also excited about. So, for example, I see customers who use the output of a series of screens to determine the best chromatographic method to separate compounds, and they're feeding the output of the results of these screens into an AI system with information about the chemistry. And then they have the AI predict which chromatographic methods are likely to be the best for a specific type of chemistry. So by archiving the data and thinking ahead, we've made making this data into an organizational asset. And we're really driving the future of chemical innovation and enabling people to do more faster and better.
Yeah, I mean, and that's really cool. I mean, I think, well, first of all, I like the fact that you picked chromatography rather than NMR example, because I'm keen that in chemists or scientists' perceptions, Mestrelab gets out of that NMR box. And don't get me wrong, I mean, of course, we should be perceived as being the best at dealing with NMR data, but we do many other things as well. So chromatography is a great example. I think chromatography is also very cool because in the context that you are explaining, by avoiding doing unnecessary or not likely to succeed chromatographic experiments, we are having an environmental impact, because chromatography is not the most environmentally friendly technique or approach to analysis that we have. But also you're talking about doing more faster and better, which to me is super important, because in the end, our users, our customers are working on things that have a lot of social impact, things like, for example, developing drugs that will be used by patients. If we can make them more efficient, then we can get these drugs quicker to the market, we can get better outcomes for patients, etc. And I always kind of like to think about how these automations, which are a little bit mundane, if you like, in the big context of things, right? They're just a very specific thing, a tool that sits in a laboratory. I always like to think about what they contribute to the big picture as well. Maybe I just want to go back to something that you mentioned earlier when you were talking about Mgears. You talked about a no-code automation engine. And, that caught my ear. And possibly because I'm not very good at coding, I don't really do it. So anything that says no code for me is already a winner, a plus sign. So what do you mean by that? What does it mean that Mgears is a no code automation engine?
Yeah, I'm not coding expert either. And there's this real common misconception that to automate things, you need to be able to write, Python scripts or have some in-depth knowledge of one or several other scripting or coding languages. And it's just not true. No-code automations have been around for a while, and they're running behind loads of business processes. I've seen them running to help people with diary scheduling and stuff like that. I mean, really, you'd be surprised. They're everywhere. I mean, they're the future of automation because they're just making it so much more accessible. You set everything up using a nice graphical user interface, and then you just click a button and set it running. These no-code interfaces, I mean, they're fairly new in the chemistry world, and that's another reason why I'm so excited about Mgears. It's not just a powerful tool that needs an expert to set it up and it runs like it's a kind of black box. Mgears has been designed so that chemists and spectroscopists can configure and deploy automated processes and benefit from them immediately. There's no need to learn scripting or code. You can see exactly what you're setting up, and it's really super intuitive as well as flexible and really powerful. And I really think the development team at Mestrelab who created Mgears are absolutely brilliant. They've done such a good job. It's amazing.
Well, I can see you like it at least a bit. And great, because it sounds like there is still hope for me then, since I don't think there is much chance I'll get coding anytime soon. Okay, so I think we learned a lot today about how automation is started to play a role in the chemistry, well, in the scientific chemistry research, etc. world. I guess many of the things that we discuss are also applicable to other close fields like biotech, etc., or biology. Biological chemistry and whatnot, and I think we probably are, we need to be getting the discussion to an end because I love to talk much more about it, but then it wouldn't be a podcast anymore, at least in the way that these things are normally formatted. So maybe the most important question of all, and this is a question that I think humans have been asking themselves, at least that I know of, since probably around the 1780s. When the Luddite movement reacted to the advent of automation in the textile industry in the UK. Are these automated processes threatening the jobs of scientists? Are they going to replace scientists, in your view? I mean, obviously, this concern is being with us for 250 years. We always think, to me, in a way, it's funny because new automatic routines come along and we always think people are going to end up with nothing to do. And then we find, I don't know about you, but I'm probably doing more than I was ever doing before, despite all the tools that are available to me, right? But what's your view on this? Is this a risk to the scientist's livelihood?
No, absolutely not. I don't think automations are ever going to replace humans. And honestly, I don't think they should. They're never going to be capable of replicating the complex and fuzzy thought processes of humans. And they'll never be able to make the insightful and innovative logical leaps that humans make. And really, in the end, it's those insights and leaps of faith that what make humans unique and drive progress and development and innovation. What I do think is that we can accelerate development and innovation if we free up the time and, more importantly, the energy and passions of our team. If we start offloading all the routine tasks, then they're always the same and they're repetitive, and we change them into automated processes and give our teams time back to focus on solving bigger problems and generating new insights and ideas. I mean, for me, the future of chemistry is really exciting. But it's not really the future, it's now. And it's all about making the best use of automations to make our lives better. And I mean, making our lives better by solving big scientific problems and creating new drugs to combat big and small health problems. But more than that, by making the everyday lives of the scientists working hard every day to solve those problems better. By lightening their load and freeing up their time to be more creative and innovative, we're giving them the possibility to work meaningful problems and to solve them faster and more efficiently than ever. So the science benefits, the scientist benefits, and ultimately we make everybody's lives better.
That's a big statement. I think a very cool one and a great way to finish this first conversation, and I like the way you're kind of casting our efforts a little bit like rebellion heroes, going back to the Star Wars analogy from earlier. So we can leave it here for today. Let's get back into our X-Wing fighters and continue the fight or continue the work. Niccy, I'm very grateful for your time and the insights that you have shared with us today. I think it's a great first discussion. So everyone, Dr. Niccy Tonge, Queen of the Universe and Strategic Account Director of Mestrelab. And this is the first episode of the Mestrelab podcast series on analytical data workflow, automation, and integration. The rise of the robots. And it turns out that, even though I didn't realize, we're actually talking about the rise of the scientist. So thank you very much, Niccy. Pleasure talking to you.
Thank you very much, Santi. It's been great.
I hope you enjoyed it, and it's been a pleasure.
You can find all MestreCast episodes at iVoox, Apple Podcast, and Spotify. And you can, of course, follow us in our Mestrelab media channels on LinkedIn, X, Instagram, Facebook. Please follow us, share us, and we look forward to seeing you attending future episodes.